Hello and welcome back to solving trigonometric equations. This is lesson 2b. So looking at example 2 from solving equations of the form a cos squared x plus b cos x plus c equals 0 and a sine squared x plus b sine x plus c equals 0. So let's look at one with sines. We looked at a cosine one earlier on. So exactly the same method for solving it. So we have a quadratic in sine. So we would factorize just like we would factorize 3x squared plus 8x minus 3 equals 0. So we do need to subtract 3 from both sides to start off with, guys. Before we factorize, we must have everything on the left-hand side equal to 0 before we can factorize. So it'll be 3 sine x and sine x, because that'll give 3 sine squared x. And then looking at where the 3 is coming from, so it'll either be 1 and 3 or 3 and 1. So we'll try different combinations. Multiply out in our head to make sure we get plus 8 sine x. Let's just check that I get plus 8 sine x here. So 3 sine x multiplied by 3 is 9 sine x. Minus 1 multiplied by sine x will be minus sine x. So I've got 9 sine x minus sine x. That does give me plus 8 sine x. And I've got minus 1 multiplied by 3, which does give me the minus 3. Okay, so we just need to factorize first. Again, as I said up here, if you really want to write, in this case, it will be 3s squared plus 8s minus 3. We must make a statement similar to this. So I would be writing let s equal sine x. Then we'd factorize. Then after we've done this line, or the line equivalent to that line, then we must rewrite it like this. Okay, that must be done or you will be thrown away a mark. So we factorize, so we have bracket bracket equals 0. So just like we're solving a quadratic with x's, we'd find out when each bracket's 0. And in this case, we're going to do exactly the same, except we have a trigonometric function in the bracket. We have a sine in the bracket. So 3 sine x minus 1 equals 0. Add 1 to both sides, divide through by 3. We are working in radians, so make sure you're in radian mode. Use our cast diagram, so we're looking in the first and the second quadrant. So it'll be 0.340 and also pi minus 0.340. Now this one's important. You need to listen carefully here. So sine x plus 3 equals 0. Subtract 3 from both sides. Sine x equals negative 3. Now, if you put that into the calculator, you'll get the maths error answer. So why do we get maths error? Well, there's the sine curve. And by putting that into the calculator, we are basically asking the calculator, when is the sine curve at a height of negative 3? So by saying maths error, your calculator is basically telling you never. The sine curve never goes to a height of negative 3. If there was a number larger than 3 at the front here, 3 or larger, it would go down to that height, but we're saying when is y equals sine x, which goes up to 1 and down to negative 1, when is that at the height of negative 3? It never is. So your calculator tells you maths error, so what you need to write here is no solutions. So what you might be thinking is, well, what's the point in writing that? So by writing no solutions, you are showing that you understand why there's no solutions, or at least you're writing down that you know that you need to say that there's no solutions, even if you don't quite understand what's going on there. If you leave that blank, you are not separating yourself from a pupil who hasn't got a clue what's going on and is just leaving it blank because they've got maths error and they're thinking, I don't know what to do. Okay, so you need to show that you're above that pupil, so to speak. So to get your mark, you have to be writing no solutions. Okay, so that gives no solutions, so it needs to be nice and clear. So my only values of x would be 0.340 radians and 2.802 radians.